Okay, this is going to be part 2 of the video series that involves the trigonometric integrals of sine and cosine. Now, if you haven't done it yet, definitely watch the part 1 video because it will show you how to set these problems up, and I'll assume when we're running through this one that you have watched the part 1 videos, so you won't need to see that again in this video. So watch it if you haven't done it. Now, what we'll do in this video is this. We're going to specifically look at this first form here where the power of the sine is odd. Then in the next video, we'll look where the power of the cosine is odd. But on this video, we're going to concentrate on this. And we'll work a couple of problems, one of them where you need this rule, and then another one where you don't need this rule. Now, before we get started, just a reminder, you will need a couple of identities and derivatives, so let's take a look at those. And again, from trigonometry, remember, the derivative of the sine squared gives you 1 minus the cosine squared, and the derivative of the cosine squared gives you 1 minus the sine squared. Then you'll also need a couple of derivatives. In this case, the derivative of the sine gives you the cosine. The derivative of the cosine gives you the negative of the sine. So you'll need to remember those. Okay, now back to our rule here. Now again, what the rule says is this. If you're given a function in this form and you want to find the integral, you've got the sine raised to a power and a cosine to a power. If the power of the sine is odd, then the rule says save one factor and convert the remaining factors to cosine. Now again, we talked about this and demonstrated all this in the first video, so I'll assume that you're pretty familiar with it. So with that, let's go ahead and try an example now. Okay, in this first example, here's what you've got. The integral of the sine to the 5th times the cosine cubed, and then 2x for the argument. Now again, both these are odd, but we're going to go ahead. Normally, I would work with the one at the highest power. So what I'm going to look at is this. This has got the sine raised to an odd power. So what the rule says to do is to take one of your sine factors, move it off the side, and save it. And this is what we did in that first video. So when you do this, what we'll do is we'll change it into this right here. It will become the integral of the sine to the 4th of 2x. Then here's the cosine cubed. And what we'll do is take one of those sines and we'll move it all the way over here and just put it over on this side. So now you've got a sine of 2x right here. So you had 5 sines, you move one of them over here. Now the whole reason for doing this is this part right here, again, is going to turn into what you're going to get rid of when you do use substitution. So all these problems involve use substitution. So the whole purpose of moving that sine over is when you take the derivative of the cosine, the derivative of the cosine will give you a sine, and then you can go from there. Okay, as we talked about again in the part 1 video, the next thing to do is this. Change this into the integral of, and you've got a sine to the 4th power in a little algebra trick here. Change it into the sine squared of 2x squared. So again, sine to the 4th is the same thing as the sine squared squared. Now the reason you're doing this is that you have an identity for the sine squared, but you don't have an identity for the sine to the 4th. So you have to change it into this form. Then you'll still have to write this cosine cubed of 2x. And then you still got a sine of 2x dx. So this little step here is actually one of the more important steps. Change the sine to the 4th into the sine squared squared. Now again, the reason you do that is that you can now do this. On the inside here, the derivative, or not the derivative, the identity for the sine squared, you can change a sine squared into an 1 minus the cosine squared using this identity right here. So the sine squared is equal to 1 minus the cosine squared. Now the reason you're doing that, you want to take this entire thing right here and change it all into cosines. So what this is going to give you is 1 minus the cosine squared of 2x. Now the whole thing is still squared. And then you've got it multiplied by the cosine cubed of 2x. And you still got this sine of 2x out here. So again, now the purpose of that, again, is to change this entire thing into cosine. Okay, now the next thing you've got to do, you've got this thing squared, so you have to FOIL this. multiply 1 minus the cosine squared times 1 minus the cosine squared. And when you do that, it will turn into this. It would be 1, then minus the cosine would give you minus 2 times the cosine squared of 2x. And then finally you'll have a plus, and cosine squared times cosine squared will give you a cosine to the 4th of 2x. Then you've still got the cosine cubed of 2x. Then you've still got the sine of 2x dx. So in that step, the whole purpose of this one, I think we'll kind of outline it here. What you did there was you foiled this thing and it turned into this right here. So this part right here turned into this. Okay, next step. Now you need to, you've got this entire thing times the cosine cubed, so you need to distribute this cosine cubed to all three of these. So we'll go ahead and move our screen down just a little bit here. So this is going to become the integral of, now again, 1 times the cosine cubed would give you the cosine cubed of 2x. Then you've got minus 2. Now again, add the exponents. Cosine squared times cosine cubed. 2 and 3 would give you cosine to the 5th power. So the cosine to the 5th of 2x. And then finally you've got plus, and again, add the exponents. 4 plus 3 will give you a cosine to the 7th of 2x. And then all of this is still times the sine of 2x dx. So you've got it spread out like that. Now at this point, it's actually going to turn into a use substitution problem. I think I'm going to put one more step just to make it a little bit more clear in here. I'm going to write this cosine as the cosine of 2x cubed. Now you don't have to do this, but it might make it a little bit more clear on why you're using a certain use substitution. I'll write this as the cosine of 2x to the 5th power. And then on this last one, I'll write it as the cosine of 2x to the 7th power, put parentheses around the whole thing, then all times the sine of 2x. Now just keep in mind, in my use substitution, what I'm going to try to get rid of will be this part right here. And so I need to find some way to eliminate that sine of 2x. Now, if you look at these, each one of these has a cosine. You've got a cosine of 2x here, you've got a cosine of 2x here, and you've got a cosine of 2x here. Now, the derivative of the cosine will give you the negative of the sine. So at this point, you're going to do your use substitution. So let's go ahead and we'll take care of the use substitution in the problem right now. Again, we'll scoot things down a little bit. So what I'm going to do is let u be equal to the cosine of 2x. That means that the derivative of u with respect to x would be equal to the negative of the sine of 2x. But remember, this is a composite function, so you also have to take the derivative of what's on the inside, so this would be times 2. So I'll rewrite this as du would be equal to, and I'm going to take this 2 and move it out in front. So negative 2 times the sine of 2x dx. Now again, over here, I've got a sine 2x, sine 2x. I don't need this negative 2, so I'll move it to the other side. So that'll be negative 1/2 du would be equal to the sine of 2x dx. Now in my use substitution, this part right here matches up with this over here. So there's my use substitution right there. I'll substitute 1/2 du. So now we keep going on. Let's move this down a little bit. Okay, next step. We'll rewrite this as the integral of, and then in here I'm going to have, this will become u cubed minus 2, this will be u to the 5th. Then you've got plus, this will be u to the 7th. So replace each one of these with u. So you had a u here, you had a u here, and you had a u here. Okay, now this one, replace the sine of 2x dx with minus 1/2 du. So we can replace that with minus 1/2 du. Okay, next step. There's several steps in all these things. Next step, here's a constant. Go ahead and bring this constant to the outside. So this would be equal to 1/2 the integral of u cubed minus 2u to the 5th plus u to the 7th du. Oops, and it should have a minus in front of it, so a minus 1/2. Okay, go ahead and find the antiderivative of those, and you'd have minus 1/2 of, now each one of these will become, this will become u to the 4th divided by 4 minus 2. This will become u to the 6th divided by 6. And then finally plus u to the 8th divided by 8. And then you can tack on a plus c on the end of this. And you're almost done now. The last step is just to replace u with what it's equal to and to distribute that 1/2. Well, again, just a reminder, we'll back up just a little bit here. U itself was equal to the cosine of 2x. So everywhere you've got a u, replace it with that cosine. So the final answer will look like this. First of all, we'll distribute the negative 1/2. So in this first term, it will give me a negative 1/8. So a negative 1/8 of u to the 4th, but that would be the cosine of 2x to the 4th. Then you've got, first of all, we'll take care of the 2's. Here the 2's will cancel out, the negatives will cancel out. So you wind up with a 1/6 right here. So plus 1/6 of, you've got u raised to the 6th power. So again, replace u with a cosine. The whole thing to the 6th power. And then finally, you've got this last term. So go ahead and multiply the 1/2 through. Negative 1/2 times 1/8 would give you negative 1/16. And again, you've got u to the 8th, but replace u with a cosine. So the cosine of 2x, the whole thing to the 8th power, and then tack on a plus c. So eventually, you get to this. And that's what the solution problem is going to look like. Now again, just kind of run through the steps. In the very beginning, first of all, it's sine to an odd power, so take one of the sines and move it over here to the side. Next thing, change it from sine to the 4th into sine squared divided by squared. Then change that sine squared into a 1 minus cosine squared. Now your goal here is to change everything but this last term into cosine. FOIL it out, distribute the cosine, and that gets you basically down to a u substitution problem now. So now you've got it all in terms of this. So let u be equal to the cosine. You can actually plug it in 3 different places. Do your u substitution. The whole problem turns into a u substitution problem. Find the antiderivatives, plug the cosine of 2 over x back in, and you're done. Now let's do this. Let's go back up and show you a variation on this problem. In this case, you had the sine of 5th times the cosine cubed. And it took a lot of work, and you had to use these rules right here. So you had to save one sine factor, convert the remaining factors to cosine, go through u substitution. The whole thing took a long time. Now let's take a look at another problem that looks almost exactly the same, but you will not have to go through this entire process, and let's look at why. So let's do this. Let's first of all go back to the original problem. Here's what the problem looked like. Now let's take a look at a new problem that looks like this. The new problem, the only difference is, rather than having this cosine cubed here, you've just got a cosine to the 1st power. Now, whenever you've got one that looks like this, if you've got a cosine to the 1st power here, you do not need to save a sine and go through all that work, because look what happens. The derivative of the sine is the cosine, so this just becomes a very straightforward u substitution problem. So let's go ahead and work this one out. So again, as long as you have a cosine to the first power, if you can recognize it, you could let u be equal to, I think we'll do it right here, we will let u be equal to the sine of 2x. Then the derivative of u with respect to x, the derivative of the sine is the cosine, and then don't forget to add that 2 on the side, and that gets you to du would be equal to, move the 2 in front, and then you've got a dx right here. Now again, in your u substitution, you're going to eliminate this, and so you don't need the 2, so that means that 1/2 du would be equal to the cosine of 2x dx. Now here's your u substitution. You've got, there's the cosine of x, 2x, and you're going to substitute 1/2 du. So in the problem, here's what it will change into. This will turn into the integral of u to the 5th times 1/2 du. Notice, much easier than that previous problem. So this will become 1/2 the integral of u to the 5th du, which would become 1/2 of, this will be u to the 6th divided by 6, and then tack on a plus c. And then finally that'll become 1/12 of u to the 6th plus c. And then finally in the last step, substitute u with what it's equal to, and u was equal to the sine of 2x, so this would be the sine of 2x, the whole thing to the 6th power plus c. So notice, this is much easier than the other one. So when you're given these two types of problems, again, my suggestion would be always look at them. Just because you've got a sine raised to an odd power and a cosine does not mean that you have to go through all these steps. If you can get by with just basic substitution, take advantage of that. So on some of the problems, you'll have to go through factoring out a sine and changing the other factors over. But again, anytime that second term, if it's a cosine or a sine to the first power, then you can take advantage of this little trick. So again, if this is to the first power right here, you don't have to do that entire long process. So one of these, just to show you again, if this was cubed, it took a lot of work and you had to go through the whole process. But if this was to the first power, then you can do a direct u substitution and not nearly so long. So again, whenever you run across these types of problems, always look to see if you can get by with a direct u substitution before you get bogged down in all this long method here.